Today we're going to start solid geometry, that is three-dimensional shapes. So three-dimensional figures, or solids, can be made up of flat or curved surfaces, either one. Okay, but it's got to be some sort of surface. Each flat surface is called a face. Okay, so if we think of this room as being like a three-dimensional solid, pretend that this is filled with concrete or something, and we're not here. All right, the walls are faces because they're flat surfaces, sort of. The floor is probably a better example of one, as is the ceiling. Those are all faces because they're flat surfaces. So basically anything you can lay your hands on is going to be a face. Okay? The intersection of two faces is called an edge. So, again, back to the room. That would be like where the ceiling meets this front wall. You see that rail up there? Makes a line? That's an edge. Yes?
Can you have one where three sides meet?
There are no sides.
Faces, my bad.
Three faces. If three faces meet, you get a vertex. So that point up there is a vertex. It's where three different faces meet. The front wall, side of this column, and the ceiling all meet together there. That's going to be a vertex. So the intersection of two edges is going to be a vertex. But you're also going to have at least three faces meeting there. Sometimes more than that, but generally just three. Okay? So a prism, not a prison, but a prism with an M at the end, is formed by two parallel, congruent, and it depends on who you are. Some people say polygonal, people say polygonal. I think polygonal sounds correct. Faces called bases, connected by faces that are parallelogram. So, back to the room again. In this room is like a prism. Okay? What are the two parallel congruent faces in this room? The floor and the ceiling. The walls are not. No two walls in this room are the same. Okay? So the floor and the ceiling are the bases. Again, let me caution you, top and bottom is not always the base. Okay? Now, it says that the other faces have to be parallelograms. Most of the time, they're going to be rectangles. But they can be a parallelogram as well. So in the room, all of these pieces of walls, because this wall is all broken up, right, are those parallelograms. Okay? So if you have a prism and there's something that's not a parallelogram, that's the base. No matter how it's turned or twisted or flipped over or laid on its side, whatever is not a parallelogram is the base. Now, if they're all parallelograms, then we'll just use the top and the bottom as the base. Yes, ma'am?
How come if it has to have two parallel bases,
Yep.
that those like pyramids are sometimes called prisms?
Pyramids are not prisms ever.
Okay.
They're a type of solid, but they're not prisms.
Okay.
Okay? And that's exactly why they're not, because they don't have two parallel congruent faces.
Because don't people like sometimes like hold one up, like those glass ones, and they're like, I'm holding a prism to the sun to make like the
Okay.
light.
That is a prism because the top and the bottom of that are typically triangles.
Oh, it's not a pyramid?
It's usually not a pyramid.
Oh, okay.
Now, you can refract light with a pyramid also, but that's not a prism. Okay? All right. So here's an example of what we will typically call a rectangular prism because the top and the bottom are rectangles. This would be a triangular prism because the top and the bottom are triangles. You always name it by whatever the bases are.
Well, it
No.
You said we had to figure it out.
Yeah. So whatever is not a parallelogram is going to be the base for a prism. For a cylinder, you also have two congruent circular faces, or two parallel congruent faces, but they're circular instead of being some sort of polygon. And those are going to be your bases. So, cylinders, it's a little easier. It's always the circle that's the base. Whether it's standing straight up and down or laying over on its side doesn't make any difference. The circles are still the bases. Now, to your point, a pyramid is formed by a polygonal base, and it can be any polygon. And then triangular faces that meet at a common vertex. Typically, when you think of pyramids, you think of one that has what kind of a base?
A square.
A square, right? The Mayan pyramids, the Egyptian pyramids, those have square bases. Those are the kinds you're most familiar with. But you can have a hexagon for a base. Heck, you could have a trapezoid for a base, although that's kind of weird. Yes?
So would it have more than 3 sides if it was a hexagon?
More than 3 sides. There are no... So, again...
3 faces?
Yes. Yeah, it would have a base, and then it would have 6 faces going up to the common vertex.
Are there any pyramids like that in real life?
Sure. Now, not like giant ones like that, but there are things that are made that are in that shape.
Oh, I never even noticed the square pyramids have 4 sides.
Right. Well, again, let's not say sides.
4 faces.
Yeah, actually, they have 5 faces total. They have 4 on the sides and then the one on the bottom. So that's 5 total faces.
Oh.
We're going to come up with a name for those in a second, and it'll be easier to talk about it. Okay? And then a cone, everybody knows what a cone looks like.
Ice cream cone.
Yeah.
We should do like a math thing with cones and then eat ice cream. Yeah.
That sounds like a great idea. All right. So, moving on to actually finding volumes and areas of prisms and cylinders. So, a lateral surface is any surface that is not one of the bases. So, Sammy, when you were talking about the pyramids, the sides of the pyramids, those are the lateral faces, is what we'll call those. And that makes sense because lateral means to the side, right?
I thought lateral meant up.
No. If you move laterally, that's side to side.
What's up? Vertical?
Vertically.
Oh. Then why is it the horizontal area?
Hey, you could make a case for that.
Okay.
But it's not all horizontal, though. Horizontal just means that. Lateral means you're moving from side to side, so it can be more than just a line moving. So the lateral area is the sum of the areas of the lateral surfaces, or the lateral faces. So you can find the lateral area, and this is the way we actually did it back in 7th grade, is we found the area of all the little pieces and added them together. We're going to find that there's a slightly shorter way to do that. The surface area is the total area of all the surfaces. That includes the 2 bases. And then the volume is the number of non-overlapping unit cubes that will exactly fill the interior. So remember, with area, it's the number of squares it takes to cover something. With volume, it's the number of cubes it takes to fill something. All right, so here's a picture of a prism that has been opened up. Think of it like it was made out of paper and they cut it along the dotted lines and folded it out, right? It's called a net. It's not important that you know that it's called a net, but this is a net of a prism. So notice in this case, it was a triangular prism, and I had these 3 lateral faces. Sort of like on the homework problem last night, where you were doing the triangles, and you could do them all individually, but you could also do it all at once. That's the same idea here. This distance is going to be the perimeter of the base because this distance and this distance are the same.
Oh, like if you folded it back up?
Right. And this distance and this distance have to be the same. So if I add these three pieces at the bottom of the lateral face together, I get the perimeter of the base. So for a right prism or for a cylinder, these are the three formulas that you'll need to know. The lateral area is the perimeter of the base times the height. So let's write that P stands for perimeter of the base. So the first thing you're going to have to do is decide, well, which of the faces is a base? And then the H here is the height of the prism. And the height of the prism is the distance between bases. How far is it from one base to the other base? So it's the difference between the bases. For a cylinder, all we have to do is change perimeter to circumference, which makes sense. Circumference of a circle is the same idea as perimeter of a polygon. The circumference is the distance around something. The perimeter is the distance around something also. So that makes sense. The surface area then, we're going to take the lateral area that we've already found and add on the area of the two bases. For a cylinder or for a prism, there's always going to be two bases. And then the volume is the area of the base times the height. So I want you to think about something for just a second. So let's imagine that we actually had one of these and it was hollow and the top was removed. Okay, and we started pouring water in. What's the first thing that's going to happen? It's going to start filling up, right? And what's going to get covered first?
The base.
Yeah, the base. And you're going to get one layer deep, right? Well, that's going to be the area of the base times that one layer, right?
So we times it by all layers.
Exactly. We multiply it times how many layers deep you needed to get the volume. Okay? Again, that's something that we did in 7th grade also. I know, you've slept since then. It's okay. All right, so let's do some example problems. And I really should have left more room. You're going to either have to write small or get another piece of paper. Either way is fine with me. So for this first one, what I suggest that you start by doing is identifying the bases and then finding the perimeter and the area of the base. If you do that first, then it's just substituting into formulas and going. So this is a rectangular solid, so we'll assume that the bases are the top and the bottom. So those are our two bases. So the perimeter, let's see, that's going to be 6 plus 8 is 14. We'll have two of those, so that's going to be 28 centimeters. The area of the base, and we'll use capital B for that, not a lowercase b, so we don't confuse it with the length of a base. How are we going to find that? Yeah, now it's the base times the height of the base, not the height of the prism. Two different heights. So that'll be 6 times 8 is 48. So then the lateral area, again, if we were to cut this open and fold it out, you'd have this big rectangle. whose bottom would be 28 and whose height would be 12. Yes.
What did you do for perimeter?
I added 6 and 8
Oh.
and 6 and 8. So it's the perimeter of the base times the height of the prism. So it'll be 28 times 12, 336, I think. Anyone who wants to double check me, that would be great. Thank you. Square centimeters. What did it ask me to find next? The surface area. So for the surface area, we've already got the area of the sides, right? That's the lateral area. But I need to add on the area of the two bases, the top and the bottom. So that's 336 plus 2 times 48. 4 less than 100, so 432. Again, you should always check. Thank you. And then the volume is simply the area of the base, because when we start filling it, that's what's going to fill first, one layer deep, times the height, which is how many layers we're going to have. So that's going to be 48 times 12 is 672 cubic centimeters, because it's how many cubes it would take to fill the object.
576.
576? What did I do wrong? Oh, yep, sorry, my fault. This is why everyone should check me.
Why wouldn't it be 672? Because isn't that double 336?
I'm sorry?
Isn't that double 336?
No, it's not going to be double this, because it's 28 times 12, not 56 times 12. Yeah, I was thinking that this was 24, and so, oh, that's just double.
That's what I thought too. My bad.
Great minds thinking alike.
I know, right?
All right. Any questions about that one? All right. This one, they didn't draw the figure for you, but they told you what the base was. The base is a regular hexagon, where the base edges are 8 inches. So we'll just need to find the perimeter and the area of the hexagon. So that's 8. So the perimeter, that's really easy. It's just 8 times 6. It's 48. Now I need to find the area of the base, capital B. What formula do I use for the area of a regular hexagon?
Half A P.
And what does the A stand for and what does the P stand for?
Apethym and perimeter.
Good, the apethym and the perimeter.
Okay, Sam.
So let's see, that's going to be 4. The whole central angle would be 360 divided by 6 is 60. So this is 30 degrees. It's a 30, 60, 90 triangle. How nice is that? So the apethym will be 4 times the square root of 3. So that's half of 4 square roots of 3 times 48 is 96 square roots of 3. Why aren't you?
Because it's literally like 24 times 4 times 3.
All right, so then the lateral area, all the way around the base, times the height. A way to think about that is, if you were painting the room, right, you just paint the walls, right? Typically, if you're painting it a color, you have to go all the way around, right?
Yeah.
And you have to go all the way from the bottom to the top. It's the perimeter times the height. Okay? So that's going to be 48 times 8 Oh, times 4. My fault. See, it's 96. 192 square inches. The surface area is the lateral area plus. With a prism or a cylinder, we've got two bases. So that's going to be 192 plus 2 times 96 square roots of 3. Is 192 plus 192 square roots of 3 square inches. And then the volume is area of the base times the height. So that's going to be 96 square roots of 3 times 4 is 384 square roots of 3. And that'll be cubic inches.
Will we ever have to combine these?
Combine them, what do you mean?
Add them all together?
Well, you can't add area and volume because they're not the same kind of thing.
Like, not combining them together, but like putting them all in like a. When we would combine like terms, but they'd still be separated.
I'm not sure what you're asking.
No.
Okay. All right, so for this next one, here we have a cylinder. So instead of finding perimeter and area of the base, we need to find circumference and area of the base. What's the circumference going to be? So that'll be 10 pi. I was like, man, that's a long pause. And then the area of the base would be pi times the radius squared, where the radius is 5, so that's 25 pi. So the lateral area, instead of perimeter, it's circumference times height. Before we go any further, I do want to point out, and every now and then I have someone do this, not so much in the honors class, but in the on-level class. It's just a bad idea. There are other formulas you can use for cylinders. They are longer and harder to memorize. But every year I have some genius who looks it up on Google and is like, I want to use this formula. And I tell them, go ahead. And every year they fail the test. So I'm not saying you can't do it. I'm just saying, why would you want to? So the circumference we know is 10 pi times the height of the cylinder is 16, so that's 160 pi square feet. So then the surface area is the lateral area plus, I've got two bases to add on. So it's going to be 160 pi plus 2 times 25 pi is 210 pi square feet. And the volume is the area of the base times the height. So it'll be 25 pi times 16 is 400 pi cubic feet. Yes?
So, this is a little bit confusing. But can we just think of like the not lateral area? The surface area is like the perimeter of a three-dimensional shape, and then the volume is the area of the shape.
Well, no. But perimeter is to area in the same way that, I think this is maybe what you're thinking, surface area is to volume. Yeah, you can make that, but you can't push that too far because it breaks down pretty quickly. Marion?
Can I go to the restroom, please?
You may. All right, so for, yes?
So you said that the lateral area is like painting the walls.
Right.
The surface area is like painting the walls and the floor and the roof.
And the ceiling, yes. Yeah. Surface area would be painting everything in the room. So the walls, the floor, and the ceiling. All right, I'm not going to do all of number 4 just for time's sake and for space sake on here. I just want to point out one thing. I've given a problem like this before, and sometimes students go, I couldn't figure out how to find the area of the triangle. I'm like, well, why not? Well, the area of a triangle is half base times height, right? So they go, the area of the base is half base times height. And they're like, I didn't know how to find the base and the height. Well, if this is 12 and this is 5 and this is 13, what kind of triangle is that? So what kind of triangle is it?
Right triangle.
It's a right triangle. There's your right angle. So it's going to be half of 5 times 12, which is 30. Okay, so sometimes they won't tell you that it's a right triangle, but they will indirectly by giving you all 3 lengths. Okay, let's not do any more of that one. Let's take a look at these last ones. These are composite figures, and I want to find the surface area of the composite figure and the volume of the composite figure. I will just tell you right now that for the surface area, if you have 2 figures that make up a composite, the surface area of the composite will never, ever be equal to the surface area of one of the figures plus or minus the surface area of the other one. Never, ever, ever. It just never happens. Now with volume, you can just take the volume of one and add or subtract the volume of the other, and you have the composite volume. Volume is always easier. Surface area always requires some thought. So let's take a look at this one. So first of all, and your book does a better job of drawing them than I do by hand, but you get the idea. This is meant to be like, if you'll imagine that this is a block of wood with a circular hole drilled all the way through it. Okay? So for the surface area, I think it's a good idea to have a plan. So, because I'm going to run out of room, I'm going to write it up here. The surface area, and I always start with the bigger one. So I'm going to start with all of the surface of this block. So the surface area of the prism. Now, after I drill that hole, can I touch all of every face of the prism?
Yeah.
I've drilled a hole. Something's missing now.
Doesn't it make more surface area then?
It makes more and less at the same time. So can I touch the whole top now?
No.
No, there's a hole in the top, right? So can I touch this part that's in the circle anymore?
No.
No. So I'm going to have to subtract off. There's a circle on top minus and a circle on bottom, right?
And then plus the cylinder in the middle.
Yeah, we'll get to that in just a second. So minus 2 times the base area of the cylinder. Plus, and this is the part, you locked onto this immediately, and a lot of people have trouble with this. You can now put your arm down inside and touch a surface that you couldn't touch before, right? So what is that of the cylinder? What part of the cylinder are you touching?
Lateral area.
The lateral surface. You're not touching the bases, you're touching the sides, right? So plus the lateral area of the cylinder. If you'll make a plan, you really have to think and make a plan for this. If you just kind of start doing things, it's almost always wrong. All right, so I need to find the surface area of the prism. So for the prism, the perimeter of the base is 12 times 4 is 48. The area of the base is 12 times 12 is 144. For the cylinder, the circumference of the base is going to be what?
Pi
4 pi.
times
Yeah, and the diameter is 4, so this is 4 pi. What about the area of the base?
pi 2 and 4 pi again.
Yeah, because it's pi times 2 squared, right?
Yeah.
So it's also 4 pi. Okay? All right, so now I can find the different pieces. I need the whole surface area of the prism. So I need to start with the lateral area of the prism. That's perimeter times height. So the perimeter of the prism is 48 times the height is 20 is 960. The surface area of the prism will be the lateral area plus, I have two bases to add on. So it'll be 960 plus 2 times 144. Let's see, that's 288, that's 11, 12, 48, I think. Yes? Thank you. I was not at all confident of that. Minus 2 times the base of the circle, or the base of the cylinder. Well, that's those two circles, right?
Minus 4 pi.
2 times 4 pi,
Oh,
because we've got two circles. Plus, what else do I need to find out?
The lateral area of the cylinder.
Right, I need the lateral area of the cylinder. The lateral area of the cylinder is going to be the circumference of the base times the height. So that's 4 pi times 20 is 80 pi. So that'll be 1,248 plus 80 minus 8 is 72 pi. Right, I've got a negative 8 and a positive 80. And I need all that in parentheses, square millimeters. Yes, ma'am.
you know how for the other ones where it didn't have a hole in it, we still had to find like volume, and it was like cubed.
Right,
Why is this not cubed?
because this is surface area.
Would we only just do surface area right now?
I haven't done the volume yet.
Oh, okay, my bad.
Okay, so the volume is going to be the volume of the prism minus the volume of the cylinder. Right, because we've drilled a hole. All that material is now gone. So the volume of the prism is area of the base times the height. It's 144 times 20 is 2,880. The volume of the cylinder is also area of the base times the height. So it's 4 pi times 20 is 80 pi. So this is 2,880 minus 80 pi cubic millimeters. That's a lot of work for a problem. Okay, in the interest of time, I'm not going to do all of this one either. but let's think about it real quickly. If we're doing the surface area, well, let's do volume first. What would you do to find the volume of this composite?
Do the rectangle on the bottom and then the cylinder on the top and add them together.
Yeah, find the volume of the prism,
Yes, my bad.
and then find the volume of the cylinder and just add them together. Surface area, a little bit harder. So I would start with the surface area of the prism. Is there part of the prism that we cannot touch?
The surface underneath the
Yeah, this little circle here has to be subtracted away. Then what parts of the cylinder can I touch?
the one base faces
One of the bases
and the lateral.
and the lateral area. That's exactly right. Okay? All right. Let's quiz.
I thought you were